Perfect. So thanks a lot again for joining us this evening. And let's start this first ever session of our design platform course. Today, I'm going to present you our hosts. It's first of all me. I build in these ideas and presentations here. My name is Arina Kamalova, or Irina, as you wish to be honest. Right now, I'm working as VP Lead Software Engineer at JP Morgan Chase, and I ex-Revolut for 3 years, which is long for Revolut, and maybe ex-Yandex, which is like Russian Google. And I would say those companies helped me to build not only experience with software, but some experience around patterns and process of development. And lastly, in my previous job, I built systems to support 45 million clients all over the world. That's it about myself. I would like to introduce you now Sonali, and I would give my imaginary microphone to her. She is helping us to do this course, and all quizzes that you would see, it's Sonali's great work.
Thank you, Rina. Hi, I'm Sonali, and I have 14 plus years of experience in tech industry. I specialize especially in building and maintaining extensive scale e-commerce solutions. I currently work at Yux Net-A-Porter, and I've worked on with many big brands like Marks and Spencers, and as a consultant, I've worked with Sapient as well. So that's my tech background, and I'm very excited to be part of this course. And I hope you all learn and get a lot of insight about these patterns. So thank you for joining.
Thanks a lot. And next, I'm going to present you our volunteer, Leslie. She helped us to make this as much democratized, by which I mean as much accessible as possible, and help us to build all examples in Python. So Leslie, over to you.
Hello, my name is Leslie. Well, I'm working as a full stack developer for almost 5 years now. Yeah, my knowledge was basically in technology related to the front end, and in the last 2 years, I started to work more in the backend with Node, and now with Python and Django. And I'm here to learn as well. And be happy to help anyone.
Yeah, so Leslie helped us to make it accessible, as I said, because she learning with us these patterns, and she helped us do not overcomplicate examples and think about simple examples and challenge us. Like, is it really, is it really there? Like, is it really used, etc. So we're trying to build here the best course for you, like even having inputs of someone who also started to look at patterns just for the first time. So if you also want to volunteer and help us with input for this presentation before sessions, we are very welcome to volunteer as well for this track. Okay. Now, I would like to ask everyone, how do you think, why we have this course? Why do we actually need design patterns? Yes, Irina?
Hi. Well, they gave you a very nice framework to solve the problems that you might have had already, and somebody might have had before, and they came up with the best solution possible. And there you go. Now you can use it, and you don't have to reinvent the wheel over and over again. So design patterns are actually like super useful. I find them useful.
Perfect. Nice answer. Okay. Anyone else want to add something? Yeah, it was a very nice answer. Thank you. So how I would think about it? It's several main points. First of all, Uh, Building patterns and actually learning patterns give us very good frameworks how to show interactions between models, between services, and you will see a lot of classes diagrams. When I started to learn language, it wasn't comfortable for me to draw these diagrams, but through these patterns, I realized that actually it's a good instrument how you can show interactions. And just on the right, you can see common language, which is another point. Like you basically can say to someone, I want to do it in the way of adapter pattern. And someone would understand it quite quickly. The same you will find through the book. Table software, which is mean these patterns already tested. Indeed, 40 years ago, they were built in the big book, and the book had intention like to share with others how to make the software to be more stable, easier to maintain, easier to implement in the beginning. Like you don't need to revisit it a lot and refactor it later. So that's why we come to the next point, solve faster, which is mean then you have problem, especially if we looked at strategy pattern. At the end, we just built new strategy quite quickly. So we solve new task, new requirements from business, from vendors. It's faster. It's easy to contribute for code base to someone who also has familiarity with patterns. They look at examples, they look at code base, they recognize patterns, they don't need that much time to dive deeper or to ask you. They quickly can communicate through common language. And of course, easy updates as we run today through strategy pattern. At the end, they say, now you can add new strategy in runtime. So it's really easy to update when you already build it through the pattern. How many patterns there? So 40 years ago, they introduced 23 classic design patterns, GAN 4, which is behavioral patterns, creational patterns, and structural patterns. Right now, we go through strategy pattern, which is behavioral. And we start with them, and we will explain again why. At some point, we will have third session, very intensive, because we will cover all creational patterns. But be ready to gain a lot of insights and then find out how you are using them in your applications. And structural patterns, which more specific, I would say, than behavioral and creational. You don't use all of them in your day-to-day life, but that was very useful things, again, 40 years ago. So don't be stressed. Don't think to be perfect developer, to be really professional engineer, I need to learn by heart all 23 classic patterns. That's one of the reason of imposter syndrome, and we engage you to overcome for this. And we tell you, you don't have to know them all by heart. It's more like manuals. It's more like a dictionary that you can go through when you need it. Now a little bit about books that exist right now on the patterns and even their history. So 40 years ago, this book, Design Patterns, appeared with C++ examples, and that's a very boring book, to be honest. I even bought it in paper version because I thought that paper version will engage me to go through it, but that doesn't work in the same way how the next book is working. The next book had first design patterns that emerged in 10 years after. That's much more interesting book, and that give you much more hands-on real life experience. How can patterns be built, and when they start with bad design of the application and then they improve it. And that gave you a lot of pictures, a lot of discussions, a lot of questions and answers. So that's why we like this book. There is a bit better edition that I put forth. The only difference, it's colored. And we did book club on this book. And then we realized, okay, this book, which is new edition, it's a bit better because it's colored, but that's it. It's the same content, absolutely the same. And in between, there are also a raccoon book. That's how I call it personally, with my friends. This is design patterns, big book with examples in all languages, etc. I didn't read book, but you can find the website, and you always can consult on the website to those patterns, again, with good cartoons, with good examples. So that's another one that we will look at through this course. Okay, let's start with strategy pattern. So anyone could remind what was wrong with this design? Anyone who read this chapter?
If we want, sorry.
Okay. Okay, let's give Irina first, and Tamila, then I will give you the word as well.
Yes, thank you. Sorry. If we want to add some new type of dark, we will have an issue with, we need each time rechange for each dark something. This is time, first of all, and a lot of repeated actions.
If we rephrase it, Irina, let's try.
So there was an issue with well, at the beginning, there was an issue with the quack method, because I think for the rubber duck, it was a squeak. And so they needed to somehow refactor this into, like, override it to be a squeak. And then as well, there was an issue with the fly methods that they tried to add in, because not every duck could fly. So it was either you are adding the fly to each instance, and then they can fly differently, right? Like, I don't know, they can fly west, they can fly east, they can fly with wings, clapping the wings or not clapping the wings, I don't know. But basically, you didn't have a variability. Like, if you do add functionality, you either add it to everything or to single each one in particular, which is going to be a lot of repeating code.
Yeah, both answers correct. I would rephrase it a bit like the problem that you force children who inherit this behavior from parent duck to implement methods that they don't need, actually. That's how I would also rephrase it. Now, they try to solve it. I really like this example because they try to solve it like step by step. And I like this one because I see that there is object oriented programming principle, actually solid principle that's well violated. Just type on the slide, it's solid principle. It's
Open
one principle.
change and close for sorry, I don't remember the full name. Open for change and close for something.
Yeah, open close, that's correct, but that's not this one. Okay, let's review this one. First of all, we have solid principles in object-oriented programming, which is single responsibility, open-close indeed, least cost substitution, interface segregation, and dependency inversion. And this book will also refer to these principles as well. Here we have, yeah, I revealed it. Okay, Narmin.
Sorry, I was going to say that list of substitute because it says that if, let's say, class B extends class A, it should be able to substitute class A. But in our case, obviously, we violated this principle. That's why it's a violation of the list of substitute.
Yes, yes, that's absolutely correct. And I don't know which came first, this very popular example of duck or this book. I don't know which one was first, but when I ever was first learning about this substitution principle, they were putting ducks as an example. And it's indeed like if your object not necessary quack, then you shouldn't put quack method in parent in abstract class. So you shouldn't force your client to implement methods, clients, which is those who implement interface, for example, not only abstract class, even for interface, you shouldn't force them to implement methods that maybe they don't need. So you put only methods that's it's 100% all objects should inherit without any exception. So basically, it's about having a very small number of methods in parent class or in interface. It's better to go just with another interface. Oops, sorry. Yeah, here they used one more pattern, and I wanted to ask if anyone has spotted, because they used something else as well in this example before going to final solution. Okay, here they also use composite. They try to composite objects in this way. And let's say, oh, actually, now we come into strategy pattern. And yeah, that's formal determination of this. It's define family of algorithms, encapsulate each one and make them interchangeable. So who can tell why encapsulate? What they mean by telling here encapsulate?
Is it meaning to separate it out into like a different class, kind of then defined by the interfaces? So.
Yes, yes, it's a good example. And Pradna?
Yeah, I think Annie just mentioned it in the chat. What I was going to say, that it separates varying functionality into separate component, and so that if any change is required to that particular feature, it shouldn't affect what doesn't need to change.
Yeah, and Narmin again.
So basically, you hide the implementation details behind the class and you make it available in Java case, let's say, via the public methods. So the private fields, let's say, if we take as an example Java class, you have the private fields basically, but you expose them via only the public methods. So basically, you hide the implementation details inside the class template.
Yeah, that's a good answer. And by using interfaces, we can indeed encapsulate implementation instead of abstract class, where you have to define some implementation. You use interface, so you hide implementation for those who will implement this. Yeah, okay, this is a class diagram. Again, consult is a book if you need this class diagram to memorize. And there is few design principles that we used for strategy pattern, which is mean encapsulate, that's wise, like you don't need to open this method for everyone. Instead of it, use interfaces. Composition is better than inheritance, which is mean instead of extending behavior, we put inside another actor which will do this behavior. Yeah, and programming interfaces, not implementation. In Python, we will use abstract methods and abstract classes, but we still think about them as programming interfaces, despite we don't have keyword interface in Python. Any questions so far? Cool, thank you. Okay, if you will Google again for these patterns and going again through them and again, you will find something like 3 key concepts. So first, it's more like how to identify that in this program, you need this pattern. Yeah, you need right context. And the context is that you see the object that uses different algorithms, the same object, but different algorithms. That's quickly give you idea, maybe strategy pattern is good here and applied here. Then the next key thing is interface for strategy pattern. Again, in Python, we can think about abstract class. And in language that does not support interface directly, it's likely you can find something like abstract class or abstract methods that you can redefine with your strategy. So we are not locked with one language, which is something that you will identify then as different implementations, different strategies. And then you see that specific implementations indeed will do the trick. And the last thing, you also think about injections of this specific implementation. And that's where we say value composition over inheritance. Instead of just inherit with implementation, we compose it inside our objects, compose it inside our implementation of our main service. That's do the job. Okay, so identify that's something you can use for strategy pattern. Refactor, if you spot it now after this session, something in your workplace, go identify, consult with your reviewers and refactor, deploy, and see how it will save time next. Now we will go for examples. So first, I put it my favorite domain right now because I work in banking. So I put there interface payment strategy. Basically, payment is just about pay. However, there is so many payments method right now. If you go, if you just try to execute some payment, it will ask you, do you want PayPal payment or direct card payment? Like, what do you prefer? Which is already give you the strategy, give us the strategy. And we put there, okay, credit card or PayPal. The example is super easy. It's just to show how patterns looks like. So yeah, if we're talking about Python, again, we think about interface. It will be class with abstract method. Yeah, and we define some interface through abstract method. And then again, we define what we're going to do. And that will be different strategies. So basically, when you're trying to explain patterns through coding, you can use the simplest ever examples. You don't have to put the whole specific implementation. Now, another thing that I want to prove you that you use this pattern every day. in every single application. And let's start with Java. Let's think that you have an application that has an integration layer, and it could be anything like even if you send metrics from your application and you send them to specific HTTP servers that accept metrics, and you send it through HTTP requests. Basically, to test with behavior, you want to write tests and you start with HTTP client. You can use mocks as already built-in libraries for unit testing, but this mocked client is already another strategy of implementation of this HTTP client, yeah, or it's a gPRC client or whatever, yeah, someone who external vendor of your application. So even when you're testing your application, you already use strategy because you put another strategy to the same object, which is mock responses. So let's see, like without mocks, how it will look like. Let's say payments client in external client that we're going to do request to them. And we have string, of course, which is JSON that will return as response. And maybe some exception is going to happen. Now, if you look at our real client, which is HTTP client, and here I used Apache HTTP, one of the most popular for Java integrations for Java clients. We just create default client. We say what is the URL, and we send request. If response 100, we parse this, and otherwise we will give exception. So that's like super simple implementation of this. By the way, anyone has an idea what this pattern also could be when you send request and get response? Okay, I'm thinking, no, let's do not think about this pattern yet. So if we start in with behavior, again, we implement client, that's the HTTP client in real prod environment, and build testing client for our testing environment, which will be even our unit test. It's like another environment where we're trying to run our objects to see if they behave correctly as we expected. So basically we say the mock response, predefined response, and that will be our new behavior that we mocked, and at the same time we implemented different strategy for payments client. Yeah, if you want this example to go next, like this is user service, and this is how they send request, and when you're testing it, instead of, again, here we use, here we will make HTTP client, and I don't have the class that's initially initiated. But in testing, we will say there is stub client, basically stub client, and through this stub client, we mock our we actually in advance mock response, and that's how we can get different behavior, and that's it. So let's look quickly at Python as well. The same, we use abstract method. We use HTTP client. I hope request is something popular libraries. Then we also say, let's do stub client, which is the same. And we return predefined response, which we put in advance when we will do testing. Again, we have user service. We say which one client we will use, different composition, different behavior, different strategy. And we use unit testing, and we put there stub for this payment client, and we mock response in advance. So it's a very simple test. However, if your logic complicate, if it's becoming more and more complex, these tests are very helpful to check like if the previous one still is working. So it's very nice habit to start with tests like this. Okay, now I would like to ask you, where did you see this pattern in your day-to-day life? I'm sure someone's seen it at least once. Okay, Narmin, please go ahead. You muted.
Oh, sorry.
Yeah.
I want just to fact check the pattern you were going to say. Is it the fallback pattern you were going to say? Like if you don't get answer, you provide some stop kind of circuit breaker kind of the implementation.
That is a very good architectural system design pattern, which we call stability pattern. And I will mention it later because for stability pattern, you indeed can have different behaviors, different strategies. However, you define them like it depends on environment. For example, if you put in test environment, you say, let's do not do circuit breakers, let's fail fast if another service in our test environment doesn't work, which will help us to react quicker on test environment. But when we go on production environment, we put their circuit breaker indeed because we want to save production environments. It's a very good point, but it's another family of patterns which are stability patterns for system design. So what I put here, like strategy pattern on the low level when you do the code. But as I said in the beginning, we also will think how in system design, when you try to build microservices together, how we also can think about these patterns we were saying. So that could be one of things to compound big system design of this big system and our strategy patterns. Good. Anyone with examples from real work, from day-to-day life? Maybe you used already strategy somewhere, maybe for testing as well.
Like in the payment, like Apple, Google Pay, like strategies when you or e-commerce systems, in the day-to-day life. Even.
Yes, it's a good example. Like depends on, I don't know, what is the request came, for example. You use Apple or Android in Google Pay, yeah, or something else. Yes, Irina?
Right. I work in banking as well. So my example would be we are working with stress testing, and usually on the trades, you have different tests. And you can stress test in a, let's say, in a spots slides, you can like apply different kind of transformations. So this transformation can be in the spots, in volatility, or let's say in rates. So this might be like an examples of transformation, and we can apply them like different types of transformation that you can apply to your initial trade.
Yeah, it's good. And it's very interesting example and it's very good. Thank you. Okay, let's go next. Let's see. Oh, another thing, why starting the strategy pattern, yeah. And it's also about trying to answer why this book started with strategy pattern. So useful for regular task, day-to-day task. As I said, even when you mock your data, it's already like different behavior of your data. Testing with different strategies. And when you looked at this implementation in the book, you spotted several aspects of object-oriented programming. So as we covered today, they violated risk of substitution. They didn't tell it. I don't know why, but now you know. They violated even one solid principle of object-oriented programming principles. And yeah, I think it's a good example, step by step, how to apply the first level pattern. So even if you already have 3 different behaviors, it's already a good point to think how to encapsulate it to interface, to put it as composition in your object, and work with it in a more flexible ways, because it's maybe likely that you will get force behavior all the same, especially if your business is growing. Okay, I put it here, and I know we didn't do these patterns yet. So basically, we will come to them later. And I will put this because then you will have an access to the presentation. And when you will cover patterns, everything, you can return to the slide and think again, how we can combine them. Yeah, and my favorite example is factory patterns that we'll do on the third session, teaser. It's about you build the factory, and it's about all objects that you're going to use, and where you can put different behaviors. And when you build your factory for testing, you put their steps, the same as we did in our example for testing 1. Okay, here I said, let's consult with Raccoon. What I mean by this, I really like this website. So if I need quickly to refresh my memory about some pattern, I just go to this website. And that's something I'm going to do right now. And I stop sharing this one, but I'm going to share the whole window for you. So it will be easier. Yeah, that's the correct one. Okay. So if you go here on this website, we see again what is strategy pattern, why they created this pattern, why I also would recommend it. Sometimes when you read from different sources, different points on the same idea, you can build your own understanding even deeper, and it really helps to see different aspects, different point of views on the same, like on the same patterns, for example. And again, as you see here, they put interface, strategy, implementations, navigator, which is someone who will composite this root strategy, who will, instead of inherit it, will do composition. Yeah, and unveil the root. And I mentioned here that you can look at different code examples. So again, if you're interested in C#, you can look at C# example. And what I also like, they put here complexity and popularity. So again, for strategy pattern, I would say it's very popular, but some patterns you would find out popularity only 1 star, which is mean maybe you would never met it in your life ever. Yeah, so here you can get 3 examples. If you want to do more and more examples, I would even recommend to go through different languages that you can read and understand, because language to language example would be different, because languages are different. And that's very interesting to learn through this website, like to go more and more hands-on with patterns, like to play with them in your mind by thinking, okay, in this language, they actually went through another example because this language is meant to solve another example. So again, I would highly recommend this. And let's return to our presentation. Now I can actually use my mouse, which is also cool. Okay, now let's think about system design. So I put 2 examples for you. First, when we think about payment services, we actually have different microservices that use different systems, and here I put MasterCard and Visa because I was thinking about card payments. So even for credit cards, you have two providers in our world, two, the most popular one, Visa and MasterCard, or PayPal. So you can use them. But now if you think about microservice, it could be mobile client or web client who come to do this request for payment. And then you have three different services that can serve this payment. Depends on what they picked up. So that's one of the examples how you already think about strategies. Another one, of course, notifications. Again, you can use SMS, and I put there even providers. So Twilio is one of the most popular right now provider for SMS. You can use Gmail to send Gmail, Gmail client, and you can do enough application notifications like just push notifications that the same payment succeed. So here we think like we also have three different strategies to notify a user if payment has been succeed. You maybe do A/B testing to see like what is more preferable and cheaper, email, SMS, or push, and then we see like how many pushes actually get to the user, because when you install app, you say no push notifications, or like how good it works with SMS. Maybe SMS is the most expensive thing, but we see like on conversion rate, maybe even just change them quickly in runtime because we do A/B testing. So that's a lot about strategy, right? And another thing that's where you can also start to think bigger on the system. Distributed system. Okay, what we have there? We have routing between services. And again, we have so many strategies like round robin, for example, or we can define based on geography, like which region we pick up. Or we can say like go for request, go to the one who has least connections, or maybe have hash-based routing. So for this is when we think about some API for requests, and or even load balancer. Load balancer can define what service to pick up, microservice, through 5 at least algorithms. And we also can say, let's use for stage environment these strategies, for development of environment this strategy, and for production this strategy. So you also can think about strategy here. Yeah, again, load balancing, because load balancing is a bit different to dynamic routing, but again, at least 3 different strategies you can find here. Caching. It's a very cool example because indeed, why don't you use a memory cache when you have development test environment? But when you go to production, you have so much more data than let's do Redis, which has more capability for in-memory cache, or another like Hazelcast, I know, and other providers. Yeah, so different strategies again. Retry mechanisms, that's what we covered today. Stability patterns. It's about having different strategies, which could be, as I mentioned, circuit breaker, but also exponential backoff, which could go actually together with circuit breaker, because you can say, okay, I will turn on circuit breaker after some attempt. I turn it off, but if it failed, then I wait twice longer before I will try again. Yes, that's exponential backoff. Or just fixed retry, like, okay, every 50 seconds I check if service alive and I close circuit breaker, for example. Yeah, so now we can do a lot of fantasies. How exactly we can apply it in different algorithms. And again, we can use one strategy in testing stage environment and another for production, more like stable, more protectable one. And last, I think, data sharding. Again, if you think about how you range your data, Again, you can think about different algorithms. Complexity will be different for staging. For environment where you test, you can pick up another algorithm just to play with it. But for data sharding, I would suggest to have the same algorithm for stage testing, environment, and production. And that's it for today. So we will have several sessions in advance. And today we covered only one strategy pattern because it was introduction in patterns itself. We hope that you liked everything. You liked the book. The book also, for me, it was very important to read all this confusion. Is it possible to read from this book with so many pictures, with so many dialogues, etc.? So that's where I spend time as well. So we started today with one first pattern. Thanks a lot. And yeah, we're waiting for you next time. Next time, read two patterns, two next ones. So it's decorator and observer. First observer and then decorator. Again, we will cover how they apply it in system design, which this book does not cover. And yeah, some resources. We will share presentation. Maybe if stars will align, we will create GitHub projects, but I wouldn't really think about stars that much. But again, if you want to go through different examples, etc., you can even check how Design Patterns Classic book looks like. Okay, and we have question. Yeah, Irina?
Very quick one. How can I add myself to a Slack? Because I tried today and I couldn't.
Okay, did you try through website?
Yeah, I clicked on the website, and it said that my email is not a part of the workplace and workspace. So I'm a bit confused. Should you add it or can I add it?
It's only you who can join.
Okay.
Did you use Gmail or something else? Gmail.
Can you send me your email? I'll try to send you
A link.
an invite.
Yes.
Yeah.
Sure. Thank you. Thank you. Sorry for our organization.
No worries, it's fine. We are very worried if someone can't use pipeline to join our Slack. So thank you for mentioning this. Yeah, if anyone else have the same problem, please just let us know. Send us a mail to me personally or to womencodingcommunity@gmail.com. So we will add you as well. And I'll share in this chat right now as well. Okay, any more questions? So the last words that I wrap up with, I will recommend to not overstress yourself with patterns. Try to keep it simple. Again, try to come with the most easiest examples as we shared today. Like you don't need the most specific real-time examples just to understand how it works. You can just simulate some examples and play around it. And do not hesitate to draw diagrams to try to understand, okay, where is inheritance, where is composition, how they find out how to actually show it on diagrams. You can also use your shortcuts, like Anki cards. I used it some years ago. They help to memorize any material with some short ideas. Again, memorable. I hope this book will help a lot. Like now you think about strategies, you quickly remind about ducks and all of its funny pictures around them. So memorable is a very important part of learning experience. And if you have chance, test it on your real life projects. Ask people around, like, what do they think? Spark discussions, like, okay, tell us tomorrow, like yesterday we learned what is strategy platform. I think here and here and here we use it. What do you think? That's how you test your idea. It's not even about going and write some code and see the test, but even just put there in the channel of your team and ask them, do you think it's a strategy pattern? What do you think about it as idea? Test the idea, test understanding of the pattern, test, iterate, discuss, argue. That's how you will for sure count this absolute good understanding what is happening around patterns in this world. And after looking at everything around, try at the end, put your main points, like what exactly I grabbed from this session, from this pattern to my life, what like 3 main points. And yeah, if you have any questions, again, if you need to send something, ask something, do not hesitate to go to LinkedIn. It's a LinkedIn QR codes. And we really thank you for coming here. We already have